All right, Geometry, this is your algebra review, and I'm sorry that I didn't get this video out sooner. I felt like I tried to give you some time in class to work on it, and I know some of you were working on other things or thinking about your lesson, and so those things were before your mind. But hopefully this is helpful as we go over this a little bit. So I went over some of them in class, not all of them. So my goal is that I'm going to try to fill in the blanks on the ones we didn't do. So number 4, again, I think we had done 1, 2, and 3. Number 4 here, you're looking at the question again. Word problems, I would always say, using this model, estimate the number of customers served in 2001. Well, 2001, okay, I'm looking at that, and they tell me, I just tried to circle it, it didn't work. They tell me that to estimate the number of customers, that's what C is, the number of customers in thousands. And this is, T is the number of years after 1993. So 2001 is a total of 8 years after 1993. So all we're doing for this problem is plugging in 8 for T. All right, and then you're just solving this. Now you're going to end up getting your answer problem really quick. I just want to make sure this is in thousand. And so you have to make sure that your answer is written in thousands. So as I do this, you have 64 plus 296 plus 400. All right, we make sure that's a 4. Sorry about that. So then we add all that together and you get 760. But again, that's in thousands, so add a couple zeros there. All right, number 4, again, pretty straightforward. The number of customers estimated to be served in 2001 is 760,000. All right. Number 5, we took a look at something like number 5, and I wanted to remind you that this is nothing that you can't or haven't done. Really simple. If I give you a problem like this, hey, 2 over 3 times 5 over 4. You guys know to multiply fractions, you multiply straight across. But if you can, before you do that, you do something like cross cancel. So it makes your math a little bit easier, and you have 5 over 6 for your final answer. So that's what we're doing here. We are going to multiply straight across, but what I want to do is try to simplify these things. Now, I'm not saying that's easy, okay? You have to factor 1, 2, 3 times, but it is doable. Okay, so just my encouragement, we're trying to think through that. So what I'm going to do as I look at this top one is I'm going to rewrite this a little bit. When we factored things like this, what we wanted to do was kind of group this middle term into 2 other things. And so what I end up with is 12x squared plus 16x plus 3x plus 4. And the way I landed on these 2 numbers is by asking myself, what is 12 times 4? Okay, which is 48. And are there any factors of 48, like 12 times 4, that actually add up to 19? And 16 times 3 is 48, and 16 plus 3 is 19. That's what you have to do on this. And once you do that, you can group together this thing. So I group this together, and I group this together. These guys both have a 4 in common, so if I take out a 4, I end up with, 4x. They both have an x there. So if I take that, I end up with 3x plus 4 plus, the only thing these have in common is a 1, 3x plus 4. And what I was looking for when I grouped these was this and this. Notice those are the same. And when those are the same, this has basically been the distributive property. We distributed through a 4x and a 1. Okay, so if I rewrote this really quick, I could rewrite it like this. 4x plus 1 times 3x plus 4. And notice what I'm doing again, if I'm kind of between these 2 steps. The 4x would be distributed to both of these. That's this first term. That is first thing. And the 1 would be distributed to both of these. That's this second thing. All right? So you ended up taking this big long thing, kind of big long thing, and we made it look a little different. Okay? And again, the reason we're doing this is we're trying to figure out, is there a way to simplify what is here? All right? So all of that was simply to recognize that this now replaces this guy. Okay? So what I'm going to do, we just kind of change that one. I'm going to do some white out here. Okay? I'm going to take all of this and bring it to the front. And we're going to put it up on top here. We replace that, okay? And again, I'm going to erase my work here so I just have more room. Solve this. I'm going to do the exact same thing here. So on the second part, I'm asking 4 and 6 multiplied to 24. Are there any factors of 24 that add up to 11? Okay? Hopefully these come to mind pretty quick. 8 times 3 is 24, and 8 plus 3 is 11. So I have 4x squared plus 8x plus 3x plus 6. And again, notice that these two make up that middle one. We've just basically replaced it. All right, so you have that. I'm now going to group together these terms, recognizing that something can be factored out. So what can be factored out is 4x, and out of here, a 3 could be factored out. So we end up with 4x plus 3 times x plus 2. So again, I'm going to white all this out. We're going to move this guy down here in a second. Just to make sure it's really clear, the first guy right here, I just want to make sure we see it. This one right here, line too long. This one is the 4x from here and the 3 from right here. So hopefully you see those two. All right. So again, I'm going to take this guy, I'm going to move it up here. And I'm really looking, can I cancel anything out here? Are any of those the same? Unfortunately, they're not right now. All right. Again, just to clear some space and make sure we focus our attention one at a time. Next, what I would do is take a look at this guy. This one's actually relatively easy. So what I'm going to recognize is that they both have an x. So literally all I can take out is x, and I'm left with 4x plus 3. Okay? We're going to replace that with, they both have an x, so we factor out an x. Now, what's nice, again, here's what we're looking for. This is identical to this. I just simplified my problem a little bit. All right? And then this one here, I talked about this the other day. You have to recognize this one. When you have two perfect squares, one is a perfect square, and 16x squared is a perfect square, this is the square root of that minus the square root of this times the square root of this plus the square root of this. If I did the distributive property or FOIL here, I would end up back here. And again, I'm going to look at this and I'm going to recognize this one looks a little different, but that this guy right here is the exact same as this right here. Right? Addition is what we call commutative, which means 1 plus 2 is the same as 2 plus 1. So these are the exact same things, just switched around. Okay. So what I'm left with, after all of that, I've got 3x plus 4 times x, that's on the top. Okay, I'm going to put these in parentheses, over x plus 2 times 1 minus 4x. And that's basically your answer. I typically would write the x out in front here. All right? But that's your answer. You've simplified it as much as you can. There's nothing else that you can kind of cross out or cancel out. So hopefully that's not too bad. Again, I know it's a long process, but if you take each step and you do them, eventually you'll get to your answer, right? The concepts are not crazy. It's just the execution of it takes a little bit of time. And yes, there's factoring in there, which I know is not our favorite. All right, so Problem number 6 next. All right, again, problem number 6, what I would say is more than anything, you have to make sure that you are being organized. What this means, if I were to rewrite this guy, it is 2x plus 3y times 2x plus 3y times 2x plus 3y. All right, you're multiplying the same thing by itself 3 different times. So ultimately, the big picture, what I'd have to do is the distributive property. Oh, did that go to the same guy? And then this guy and this guy. All right, and then I'm going to do that again. So you'll see, let's just do this one first. You would end up with 4x squared plus 6xy plus 6xy. So 2x times 2x is 4x squared. 2x times 3y, 6xy. And then you do that inside the middle. And then plus 9y squared. And basically, now I'm going to take that, I'm going to bring this guy down here. And I'm going to do the distributive property again. All right, now I do the distributive property again, and I end up like multiplying this out a bunch of times. Oops, sorry, you know what? Let me make that a little simpler for us. These are the same. So before I do that, these are the same. Do this in yellow. So I'm going to write this as one term. This is actually 12x. Y. So that way I don't have as much to distribute. Okay, so I'm going to go 1, 2, 3, and the same thing 1, 2, 3. You're just distributing through a longer process. Okay, so first one, we're going to go from the very ends here. So kind of first outer inner last, but there's 3 terms, so we can't really say FOIL this time. But 2x times 4x squared is 8x cubed. All right. Then you've got 2x times 12xy, so that's 24x squared y. And then this last one plus 18 xy squared. All right. That's kind of the 2x going through. Now we take the 3y. So the 3y times 4x squared is actually 12x squared y. And notice where I wrote it. I wrote it under this one because these go together, right? You have, 4x squared, so you're going to have an x squared and then times y. Put that back. All right. Next, 3y times 12xy, so what I'm going to get is plus 36xy squared, and then plus, last one, 3y times 9y squared is 27y cubed. All right, what I end up with this big thing, 8x cubed plus 36x squared y plus 54xy squared, so 4 plus 27y cubed. Okay, that's the big, long way to do that. Now I want to point out, hopefully if you can catch this, see if I can get this all here at once, a slight little bit of shortcut. Okay, I'm not saying this is easy. There is some things you need to be aware of that. But the first term here and to here is literally this thing cubed. So all you're doing is 2 to the third power is 8, x to the third power, x to the third. And same thing here. 3 to the third power is 27. Y to the third power is y to the third. Okay. And so you're getting those ends, all right? And for these middle terms, what you're going to do is, so a little tricky here, but you're going to do 2 squared times 3 So 2 squared is 4. 4 times 3 is 12. And then you're going to, so that's this number, and then you're going to double that, which would be the 24, and you're going to add those together. And then you do the same thing. So you do, for the other side, you're going to do 3 squared times 2. 3 squared is 3 squared is 9. 9 times 2 is 18. And 18 times 2 is 36. And add those together. Now that's a little weird, but if that's a kind of a shortcut so you don't have to go through all of this distributive property, that is a way to kind of jump to a little bit more of an answer. All right. Number 7. For now, we're going to skip, and we're going to go to number 8. All right. This one, this is actually a difference of squares. These are perfect squares. So as we look at this, you're trying to recognize that the square root of this is x squared. The square root of this is 25y squared. And so when you have the difference of squares, you're supposed to add them together and subtract them. And then you're recognizing this is also the difference of perfect squares, and so I end up with this x minus 5y and x plus 5y, that's a plus, times this big thing here, x squared plus 25y squared. Okay. Again, this all goes back to, these are special cases like this one and like this one. They're really like rare cases, not as often, but there's tricks to them. If you know them, it becomes really quick. So these are like the rare cases that come up that when you have memorized, then you can recognize a little quicker. So just recognizing that this is 25 times 25, that this is x squared times x squared will help you to solve these really quick. All right, next problem. This one here, again, this is a special case. When you see this, what you want to recognize is that for the difference of perfect cubes, which is what these are, this is a perfect cube, this is a perfect cube, 5 times 5 and 5, and I believe the other one is 6 times 6 times 6. So when you have this, let me actually write it over here, a cubed minus b cubed, that's going to equal a minus b times a squared plus ab plus b squared. Okay. So you have to recognize this first, that in this situation, a is 6y to the third power. So this is a minus b, it's 5x to the third power. So to solve this, or to factor this completely, I just am going to put 6y minus 5x times a squared. So 6y squared is 36y squared plus a times b, 6y times 5x, so plus 30 xy or yx. Well, we'll leave it that way. And then plus b squared, so b squared, again, 5x squared is plus 25x. And you're done. Like, that's it. So notice this, there's just some situations that really you just need to know. And if you know them, it's a lot faster. Otherwise, you sit there trying to break down how they work, and sometimes that can get really tricky. Not that it's not possible, it just makes it a lot harder to do. So if you know the pattern, again, you can make that a little bit easier for yourself. So hopefully you could see that in there. And again, this is kind of the rule you would need to know in order to do that. All right, something like this. All right, we actually saw this earlier, where you basically are going to split this middle term. So we did this on one of the earlier problems. But you ask yourself, what are the factors of 15, 3 times 5, right? That add or subtract the 2, which is just 5 times 3, right? It's the same numbers. So you have 3x squared. This one's a little trickier because you have to pay attention to your signs, right? One of these has to be a negative. It has to be the 5. So I'm going to do plus 3x minus 5x minus 5. And again, notice that that term, that middle term, is these two together. Okay? So we do a little bit of grouping here. I'm going to include, we'll undo that. And we're going to include this negative for a second there. So we've got our groups. So this is 3x times as x plus 1. And then the second one, if I factor out a negative 5, I'm going to get x plus 1. So I had to do this kind of factor out a negative. They both have a negative so that my goal here was that these were the same, right? So you have x plus 1 times 3x minus 5. All right, so again, factoring by grouping. A lot of times you factor by grouping when you see a number in front of x squared. That's a really common situation to do factoring by grouping. All right. So this one, again, what I would do is I would just take out a negative to start. We're not used to having a negative in front of there, so factor that out. And then solve as normally, keeping this here. This one you don't have to factor by grouping, so you're going back to the other way is what are the multiples of, or factors of 18. So 18 is 6 times 3, right? So when you factor this way, you're going to set up 2 parentheses. And in order to get 18, one of the numbers has to be negative. And because this is negative, you're going to have a negative 6. So negative 6 plus 3. And again, there's a negative in front. Right? So that is factored as much as you can. All right, 13. Okay, and I think we did this one, 14, briefly in class, so I'm going to focus on this one here. Again, really simple concept. If I'm adding fractions, to add fractions, I must have a common denominator. So I want all of these to have a common denominator, and right now they don't. I'm going to start with this one. We have already talked about this is a perfect square, so I have to, a difference of squares, and so I'm going to simplify this. This is actually y plus 2 times y minus 2. If I foiled this, if I did the distributive property, I'd end up back here. So notice this is really nice. You know, this guy has the y plus 2, and this one has the y minus 1. But I'm trying to think through that a little bit. So what I have to do here is I have to get this fraction to have y plus 2. So I'm going to multiply this one by y plus 2 over y plus 2. And notice even by doing that, I'm really not changing this guy right here, right? Nothing is changing about it because I'm multiplying by 1. It's a weird way, but I'm multiplying by 1. All right? So what's going to happen is I have 5y plus 10 over y plus 2, it's a plus, times y minus 2. So now that has the same denominator as this guy. Okay. Actually, I'm going to rewrite this. We want them all to have the same denominator. So I'm going to end up with this big long fraction. Hopefully in this one, we'll get to a second. And at the bottom, the denominator will be y plus 2 times y minus 2. We want them all to have the same. So on this one, I have to multiply by y minus 2 over y minus 2. So on the top, I'm going to have minus, there's a negative here, and then I'm going to put all this in parentheses because that negative has to go through to everything. 2y minus 4. So 2y minus 4. Okay? And what happens here with this negative is really have to make sure that it is going to be a negative here, and then this is going to change to positive because that negative goes to both. So the rest of the time I'm doing this one, let's scroll down now that I've made this so big. All right? Try to keep that on there. Is I'm just simplifying or combining my like terms in the numerator. Okay, so in the numerator you've got your y's. 5, 6, 6 minus 2 is 4y. 10 plus 3 is 13, plus 4 is 17, over y plus 2 times y minus 2. And you might see them put this back together, so the final answer might look like this: 4y plus 17 over y squared minus 4. The original middle term, they might write it that way sometimes. So just so we're aware of that and comfortable with that, you should be okay. All right, again, I think we talked about that one in class. So this one, again, looks crazy, and while there's a lot going on, there's fractions added together and fractions and on top of fractions, right? So this is what I would say. Do one thing at a time. So we're going to look at the numerator only numerator. To subtract these, they have to have the same denominator, so I have to multiply this guy by 2. So this is going to be 2 over 4x. If I multiply the top and the bottom by 2, so on the top, I'm going to end up with negative 1, 2 minus 3 over 4x. Okay. On the bottom, in the denominator, again, same thing. I'm going to multiply the top and bottom here by 2, because I want this to be the same as this guy. So you got 6 over 2x plus 1 over 2x, which is 7 over 2x. Now, maybe a better way for me to write this problem is like this. Maybe this looks a little more familiar to you guys. If I wrote it this way, I feel like less of you would have a problem. If you have a fraction over a fraction, it's division, right? I'm doing this guy divided by this. And when you divide fractions, I'm going to do this in a, not really, it's not going to look right, but you flip this one over and you multiply, okay? So this was 2x. I don't want to, I'm not going to leave it that way. All right, so 2x divided by 7. Right? What we'll do is we'll get this guy here, hopefully, out of the way. Right? Originally, it was this, and we flipped over and multiplied. So now I just multiply straight across. I could do some cross-canceling here first, which we're always excited about. 2x would become 1. 4x would become just 2. And so I end up with negative 1 over 14. And there is my answer. Negative 1 over 14. All right, again, I think we did 16 in class, so we're going to jump over here to number 17. For number 17, when you're adding square roots, you can only add them if they have the same root. So all of these are different on the surface, but if I start to break these down, this is 2 times the square root of 9 times 3. You just write all of these. 7 times the square root of 4 times 3 minus 3 times the square root of 16 times 3. So notice they all have 3's in them. And the other number, 9, 4, 16, are all perfect squares. So I can now kind of rewrite this. This would be 2 times something the square root of 3 plus 7 times something the square root of 3 minus 3 times something the square root of 3. And those somethings are the square root of 9 is 3, the square root of 4 is 2, square root of 16 is 4. So the last thing I have to do is kind of like figure out what those are. Okay? So I have 6, 14, and 12. And then all the square root of 3. Right? So what I'm going to do is add all these together. I'm going to take care of my math here. 6 plus 14 is 20. 20 minus 12 is 8. And then that was supposed to be the square root of 3. I left it off the whole time, right? Because really what I care about is the number in front. Imagine if these were all x's, right? I don't add the square root of 3's together. I don't square my x's or do anything weird. I just put x. In this case, they're the square root of 3, the square root of 3, the square root of 3. So 8 the square root of 3. All right, 18. I'm going to let you guys do this one, actually. I think you can do this. This is just distributive property. So 5 plus the square root of 3. Just start you off. 5 plus the square root of 3. And you would do the distributive property. 5 multiplied through and the square root of 3 multiplied through. I think that's doable. I think you guys can handle that. All right. Number 19 and 20, they're very similar. What I would do is, first off, I'm going to make my, I'm going to see if I can reduce my fractions or change this in here first. That's always my thought process, if I can do that. Before I do that, right, parentheses first. So I look at this, I can't reduce my fractions, but I can, take care of these x's. So when you divide, exponents with the same base, you're basically subtracting. So this is x to the negative 3 minus 5, which is x to the negative 8. Okay? So I have that kind of thing. So I would kind of rewrite this. This would be 4 x to the negative 8 over 3 to the negative 2. And that negative 2 is going to go to everything. So if I were to read that right, this would be 4 to the negative 2 times x. When you have a negative exponent and then you have raising it to another negative exponent, what you really do is you multiply those together. So it's negative 8 times negative 2, which is positive 16 over 3 to the negative 2. And when you do have a negative exponent, you're going to switch its location. What that means is this value is going to come to the bottom, and this value is going to come to the top. So I end up with 3 squared. It becomes a positive on top. So 3 to the negative 2 is move it to the top and just do 3 squared. So you're going to do 9 x to the 16 over 4 squared is going to come to the bottom, and 4 squared is 16. All right. If I could reduce that, I would. Otherwise, I leave it that way. All right. And very last one, again, a little bit longer, but the same process. All right. The difference on this one, I just want to show you really quick, is that here, these were all in one parentheses. These are not, so I can't cancel these out at all yet, which is a little bit unfortunate because I'd like to do that. So I'm going to do 8, we're going to kind of distribute this through to everything. 8 to the negative 9th, x to the 9th, y to the negative 12th. What I'm doing is multiplying 3 times negative 3, negative 3 times negative 3, 4 times negative 3, and then on the bottom, 8 to the negative 20, x to the negative 10, y to the negative 35th. Okay, and then again, there's a lot there, but I'm trying to simplify in some way, shape, or form. Take each one of these individually. We'll try to do this step by step here. Look at these guys. Sorry. Okay, so we're going to focus on our 8s. When you have, again, exponents with the same base and they're divided, you subtract. So it's 8 to the negative 9 minus negative 20. So that's 8 to the 11th. Okay. Again, you're subtracting these exponents. So negative 9 minus negative 20 becomes plus. That's 11. All right. You go to the second one. You got these guys. This would be x to the 9th minus negative 10. That's x to the 19th. And then the last one here is y to the negative 12th minus negative 35. It's going to be y to the 13th. That's 25. Sorry, 23rd. Power. Okay. And that would be your final answer.